Hello everyone and welcome back to another new video of Basics of Electrical and Electronics Engineering, which is a subject for first year KTU students. Today we are going to discuss some problems related to average value, RMS value, form factor and peak factor of different types of waveforms. Let us consider first the basic waveform, pure sinusoidal waveform. So let us write down the question. Find the average value, RMS value, peak factor and form factor of a pure sinusoidal waveform. So normally they will be mentioning whether it is a voltage waveform or a current waveform. If it is a voltage waveform, then the y-axis should be voltage, and if it is a current waveform, the y-axis should be current. And similar to this, the terms also will be changing. For example, if it is sinusoidal voltage waveform, the equation for the voltage waveform is Vm sin theta, and if it is current, you have to write the expression as Im sin theta or sin omega t. Okay, so the expressions may be changing according to whether it is voltage or current waveform. The method of doing or method of finding out what is the average value, RMS value, peak factor and form factor remains the same for both cases. Let us consider first the pure sinusoidal waveform. One more thing, when we are given any standard waveforms like pure sinusoidal waveform, half wave rectified waveform, full wave rectified waveform, all those things, they will not be giving you waveform in the question paper. You have to draw it by yourself. So such standard waveforms, you should be aware of how to draw the waveform. Let us move on to first case, that is pure sinusoidal voltage waveform. So in the answer, first what we have to do is we are going to draw the waveform. Yeah, sinusoidal waveform, we know how to draw it. Okay, and we are mentioning it as voltage waveform here. Theta is equal to omega t on the x-axis, and we are going to find out what are the values. Just a minute. Before moving on to the complete analysis of each of them, first you should be aware about what is the timing of each of this one. For example, here the displacement will be pi, here it is 2 pi. This is for a standard sinusoidal waveform that you should be thorough with. And the maximum value occurs at pi by 2, and the maximum value here will be Vm. If it is current, you have to take as Im. Let us move on to find the average value. Okay, so what is the equation for finding the average value? As we studied in the previous video, average value is equal to area under the curve for one cycle divided by time period for one cycle. Okay, so what is one cycle? We have to identify where the cycle is being ending. How can we identify it? Either we can use two methods to identify a cycle. Firstly, you can calculate by looking at one complete positive and negative cycle. One complete positive and negative half cycle ends at 2 pi, so 2 pi becomes the one cycle. Or you can also identify it like where the waveform is being repeated. For example, this shape is being repeated at this point. Right, it is going like this, so the repetition is at 2 pi. So this is also another way. This another way can be used for finding out the cycle of a given waveform. So one cycle is equal to 0 to 2 pi. Next, we are going to find what is the area under the curve for this from 0 till 2 pi. Now look at this waveform. Here you can see that this waveform is consisting of two areas. One is from 0 till pi, and the second one is from pi to 2 pi. And there is another peculiarity of this area. I'll mention it soon. Now listen, we can write the total area under one cycle as area from 0 to pi plus area from pi to 2 pi. Okay, divided by, what is the time period for one cycle? 2 pi divided by 2 pi. Now look at these areas. You can see this area and this area looks same. The only difference is this one will be positive and this one will be negative. The area will be same, but it will be having opposite sign. So what will happen if we are substituting the values here? Area and this area will be minus area. So together when we are considering, the average value becomes equal to 0. Okay. So when we are calculating average value, we got the value as 0. This is because it is a symmetrical waveform. And as we are finding out the average value as 0, now we are going to find what is the half cycle average. As the average became equal to 0, we are not going to stop it there. We are going to find what is the half cycle average. So for finding the half cycle average, we are going to modify the equation of the average equation. Area under one cycle divided by time period for one cycle was the average value. Then the half cycle averages area under the curve for half cycle divided by time period for half cycle. Okay, so what is the area under one half cycle? Which means the area till from 0 till pi. We have to find the area, but we don't know directly how to find out what is the area under one sinusoidal waveform. See, look, this is a sinusoidal waveform. We have modified the equation. Half cycle average is equal to area under the half cycle divided by time period for half cycle is till pi only we need. Okay, now we cannot directly find out what is the area under the curve. Why? Because we are not familiar with the area under a sinusoidal curve. If it was a rectangle, we can say as length into breadth. If it is a triangle, we can say half BH. And going on, we are familiar with some areas of some waveforms. But if we are considering the sinusoidal waveform, we are not familiar with how to calculate the area. So in such cases, we have to go for finding the area with integration method. What is integration method? We are considering a small strip, a small rectangular strip we are considering. We are finding out what is the area of this small rectangle and we are going to integrate it from this point till this point. Area till there you have to find the or we have to integrate it and find the answer. Okay. So here you can see we are going to integrate the area of the small strip from 0 till pi. For example, let us consider here a small rectangle whose length is, what is the length of this rectangle? You can see the length of the rectangle will be changing at every instant of time. The value will be changing, isn't it? So we are going to consider the length as the instantaneous value of the voltage. Instantaneous value of the voltage, that means V is equal to Vm sin theta. Okay, and we are going to find what is the area. So length is the instantaneous value of voltage. So we are writing it as small letter V. And the breadth we are considering as small d theta, small angle theta, that means d theta. So V into d theta becomes the area of the strip, So we are going to integrate this area from 0 to pi. See, look here. So integral 0 to pi V d theta whole divided by pi. Now instead of V, what we can substitute? We know that V is equal to instantaneous value of voltage which is changing. It is having an equation Vm sin theta. So we are going to substitute it here. So Vm sin theta d theta divided by pi. So integral, totally we can say integral 0 to pi Vm sin theta d theta whole divided by pi. This will be the equation to find what is the half cycle average, and for which we are going to integrate it. Vm by pi is a constant. We are taking it outside and the remaining terms are integral 0 to pi sin theta d theta. Okay, from which we are going to integrate it. Sin theta, integral of sin theta is minus cos theta in the interval 0 to pi. Okay, and Vm by pi is equal into, giving the limits, you will be getting the values like this. Now substituting the values of cos pi and 1, cos pi and cos 0, you will be getting the answer as 2 Vm by pi. So our final answer for average is 2 Vm by pi. Okay. So next we are going to find out what is the RMS value of this pure sinusoidal waveform, for which we need the squared waveform. So first thing we have to do is we have to square the given waveform. So this was our given waveform. We are going to square it. Positive square, you will be getting another positive curve. Negative square also you will be getting another positive curve. So which means your curve will be looking like this red curve. Okay, it will be two positive curves, but it is not sinusoidal. It is actually, if it is, this one is small letter V, then this will be V square. So this is how you have to draw the squared waveform. Now we are going to find the average value, RMS value. So RMS is equal to root of area under the squared curve for one cycle divided by time period for one cycle. Here where is the cycle? From 0 till pi is the cycle here. So we are going to find the area under this curve divided by the time period means pi. Okay, so integral of, how can we find the area? Here also we don't know any particular method to directly calculate the area. So we are going to do the same method, taking the area of a small strip, then we are integrating it from 0 till pi. So area of the small strip is length into breadth. What is the length here? See, the length has increased to v square. Breadth is same, d theta. So the area of the strip becomes v square d theta. So our equation becomes root of integral 0 to pi v square d theta divided by pi. Instead of v, we can substitute as Vm sin theta. So when substituting this, your equation becomes v square means Vm square sin square theta. Okay, don't make a mistake here. Vm square sin square theta. Now we are going to substitute these values here. So integral 0 to pi Vm square sin square theta d theta by pi. Then taking the constants outside, so totally root of Vm square is a constant, pi is a constant, taking these outside, you will be getting as integral 0 to pi sin square theta d theta. But we don't know how to directly take the integral of sin square theta. We are going to change the shape or change the form of sin square theta as 1 minus cos 2 theta by 2. So Vm square by pi, integral 0 to pi, 1 minus cos 2 theta by 2 we have to integrate now. Instead of sin square theta, we are writing as 1 minus cos 2 theta. Now this 2 can be taken outside as it is a constant. We can take it outside, so the 2 is taken outside. Now the remaining term becomes like this, Vm square divided by 2 pi into integral of 1 is theta and integral of cos 2 theta is sin 2 theta divided by 2. So this 2 is only for the second term. Okay. Now putting the limits, you will be getting as pi minus sin 2 pi by 2 minus, when we are substituting 0 value for the second this complete bracket, you will be getting the value as 0. And sin 2 pi will be also 0. So only thing is, inside the bracket there is only pi now remaining. This pi and pi gets cancelled and the equation becomes, taking out of the root, we are getting the answer as Vm by root 2. So this is how you have to find the RMS value of pure sinusoidal voltage waveform. Next we are going to find what is the form factor and peak factor. So form factor is equal to, you have to study the equation, RMS value by average value. We found the RMS value as Vm by root 2 and average value as 2 Vm by pi, from which you can calculate what is the form factor. Next one, peak factor. Equation for peak factor is peak value divided by RMS value. We know that the peak value is Vm. Now we just found out what is the RMS value, that is Vm by root 2. By taking the division, you will be getting the answer as 1.414. Okay. So study this well. This is the basics for finding out how is the what is the average value, RMS value, peak factor and form factor. Okay. Thank you everyone.